Code P0 generally indicates high current protection in one of the IGBT transistors, likely due to a failure in the inverter module or an internal short circuit. Recommendations: A. Inspect the electrical wiring that powers the compressor. B. With a multimeter, check the inverter module for possible short circuits, as we will show at the end of the video. However, for HRDN series outdoor units, this code indicates compressor discharge temperature protection or overheating at the top of the compressor. Recommendations: A. Check the correct airflow and fan rotation in the outdoor unit, as well as its cleanliness. B. If the fan uses a capacitor and the fan rotates slowly, replace the capacitor. C. With gauges, check the refrigerant levels and the operating pressure with our 410A and our 32 refrigerant. With the unit running, it should be very close to 120 psi. Code P1 generally indicates protection against overvoltage or low voltage, caused by voltage fluctuations in the power supply. Recommendations: A. Verify cables and electrical connections. B. Check the power supply and, in case of issues, use a voltage stabilizer. However, for HRDN series outdoor unit models, Code P1 indicates protection from high pressure. Recommendations: A. Check that the outdoor unit fans are working correctly, and verify the capacitor if the fan uses one. B. Verify the cleanliness of the outdoor unit's coil. Code P2 generally indicates temperature protection at the top of the compressor. Recommendations: A. Check the airflow in the outdoor unit and the correct rotation of the fans. B. Use gauges to check the refrigerant level. However, for HRDN series outdoor unit models, Code P2 indicates low pressure protection. Recommendations: A. Inspect connections and check for oil spots on pipes to look for leaks. B. Adjust refrigerant levels as needed. Code P3 generally indicates compressor current protection. Recommendations: A. Check the condition of the compressor and the inverter module, as we will show at the end of the video. B. If Code P3 takes a long time to appear, check the airflow in the outdoor unit and the correct rotation of the fans. Code P4 generally indicates an inverter compressor drive error. Recommendations: A. Check the electrical connections of the compressor. B. Turn off the unit and check the inverter module, as we will show at the end of the video. However, for Midea units with HRDN series outdoor units, this code indicates high discharge temperature protection for the compressor. Recommendations: A. Make sure the outdoor unit fan is functioning correctly. B. Check the cleanliness of the outdoor unit coil. Code P5 generally indicates inverter module protection, likely due to overheating or an internal short circuit in the inverter module. Recommendations: A. Check the electrical connections powering the compressor. B. Test the power module to the compressor, as we will show at the end of the video. However, for Midea units with HRDN series outdoor units, this code indicates protection of the condenser from high temperatures. Recommendations: A. Clean the condenser and remove obstructions from the ventilation grills, and check the rotation of the outdoor unit fan. Code P6 for Midea units with HRDN series outdoor units also indicates inverter module protection, likely due to high temperature in the condenser. Now we will look at the diagnostic procedures for the intelligent IPM module and the compressor. 1. Turn off the unit and disconnect it for several minutes. Then, turn it back on and check if the problem persists. 2. If the problem reappears, use a multimeter in the AC voltage scale to verify that the supply voltage from the external source is correct. 3. If the voltage is not adequate or fluctuates, consider connecting the equipment to another power source or using a voltage stabilizer. If the voltage is within the correct values, go to the outdoor unit and check that the electrical connections are in good condition, ensuring there are no loose wires. 4. If the connections are fine, it's time to intervene in the outdoor unit. Open it and locate the compressor. With the equipment de-energized, disconnect the connector that powers the compressor. 5. Set the multimeter to the ohms scale and measure the resistance between each pair of pins on the compressor. You must take 3 measurements in total, and the values obtained should be almost equal. If there are significant differences, there may be a problem with the motor windings of the compressor. 6. If the resistances between pins are correct, check the continuity of the power cables from the compressor connector to the electronic board. Use the multimeter in continuity or sound mode. The electrical resistance of the cables should be minimal. 7. If everything is still fine, it's time to test the Intelligent Power Module, IPM, which is responsible for supplying current to the inverter compressor. Follow these steps. A. Disconnect the unit for several minutes to ensure the electrolytic capacitors are discharged. Set the multimeter to diode mode. With the positive probe of the multimeter, touch the negative polarity of the high-power electrolytic capacitors, and with the negative probe, measure one of the compressor connector pins. B. Perform this measurement 3 times, leaving the positive probe of the multimeter on the negative polarity of the capacitor, and rotating the negative probe among the 3 pins of the connector U, V, W. The values obtained should be the same in all 3 measurements. C. Next, perform the same test, but this time place the negative probe of the multimeter on the positive polarity of the capacitor, and the positive probe on the compressor connector pins. Repeat the measurement 3 times, leaving the negative probe on the positive polarity of the capacitor, and rotating the positive probe among the pins U, V, W. Once again, the values should be equal in all 3 measurements. 8. If everything seems correct, it is likely that the problem lies in the outdoor electronic board, specifically in the PFC, power factor correction circuit,